Welcome. In this screencast, we're going to take a look at translations as we begin a study in transformational geometry. Not that the geometry will change us, but we take a look at the geometry of how things change. And the most basic of transformations for me is the translation. This is the thing that your middle school teachers may have referred to as a slide. And what do we mean by that? Well, this is the coordinate grid, and let's just pretend that you have some shape, and it looks like this. This is triangle A, B, C. Now, a translation takes that triangle and just moves it around the grid somehow. It doesn't turn, it's just translated somewhere in the grid. It is slid from one place to another, maybe like so. And when it lands somewhere, we call this A prime and this B prime and this C prime. And it's worth us considering what actually happened. So to do this, let's look at how the reds become blues. This is the point 1, 2. This is the point 0, -1. And this is the point 4, -1. And what happened to those points? Well, a prime is now at the point -4, 4, and B prime is now at the point -5, 1, and C prime is now at the point -1, 1. So it's worth pausing for a moment and thinking about what happened to all the red coordinates to make the blue coordinates. We want the same thing to happen to this set to become that, to this set to become that, to this set to become that. Think about it for a moment. How did the reds become blues? Well, it appears that if the red coordinate was x, y, the blue coordinates had x's that went down by 5 and y's that went up by 2, right? X coordinate went down 5, y coordinate went up 2, x coordinate went down 5, y coordinate went up 2. And so we would describe this transformation as a translation. Sometimes we say that we translated left 5 and up 2. That's a fair way to describe the translation for our students. Okay, so just to be clear, translations always take x and y coordinates and add or subtract, add or subtract. Why? Because by adding to the x's or adding to the y's, or subtracting from the x's, subtracting from the y's, adding or subtracting to the x moves the triangle left or right. Adding or subtracting to the y's moves the triangle up and down. So if all we're trying to do is slide, if all we're trying to do is move the shape left, right, up, down, without turning, without stretching, without flipping, just left, right, up, down, the easiest way to do that is to add or subtract on the x's and the y's. So let's think about, oh, wrong way. Let's think about a second example. Let's take the trapezoid, and yes, this is a trapezoid, and let's find its image under the transformation that moves the point xy to the point x plus 3, y minus 3. Take a moment, figure out where t prime, r prime, a prime, p prime has to be if xy moves to x plus 3, y minus 3. Well, let's think about what this means. This means that we're going to move right 3, and this means that we're going to move down 3. So when we go to find t prime, r prime, a prime, p prime, from t we go right 3, down 3. From r we go right 3, down 3. From a we go right 3, down 3. And from p we go right 3, down 3. And this becomes, oh, that is just terrible. That is just terrible. We can do better than that. Commenters are going to say I mailed it in. Let's notice that trap is congruent to t prime, r prime, a prime, p prime. A translation does not change the size or the shape of a figure. The image is congruent to the pre-image. It was true here, it was true there. All the sides are congruent to their images. All the angles are congruent to their images. A translation preserves all of those properties. Okay, so this is a good look at translations. Hope that it makes sense of some of the stuff you read about. Next up is rotations. I will see you there.